All right, guys, thank you very much for joining us today for BrainX Community Live. We have an awesome session planned today, which is on AI platforms for radiology. And I'll talk a little bit about it in just a moment. You can see my screen and hear me okay, right? All right. So, BrainX Community, for those who are joining for the first time, was a platform that we created around 8 years ago with the idea that we need to share scientific knowledge about machine learning or AI in healthcare for good. Grown to be 7,000 plus members. The LinkedIn group is 3,500 plus members now. We have our website, which provides a whole host of content. We do these monthly live sessions so that we can learn from eminent researchers, uh, entrepreneurs, people who have done some amazing work. And we have two very, very exciting and very prominent speakers today in just a moment. This is our homepage, our landing page, which provides the latest updates that's to the content on the website. We have our Connect segment where we do these monthly live events where, as I said, we feature scientific information. We're not just talking about AI can do this or AI can do that. We're talking about the real science of it, the real development and real implementation part of it. And this is our YouTube channel, so please subscribe us. Even if you miss these webinars, you can find the recordings from the past over there so that you don't miss out on the content. As I said, we have a very active LinkedIn group where we share a lot of scientific publications, upcoming conferences, or other content for you. And you can actively share that too. This is our Learn segment on our website where we provide certain key publications. There are a whole host of publications coming out every single day. So we select, curate, provide you filtered option to look at certain publications for a particular healthcare specialty or otherwise. So you can go to this and see some of our featured publications over there. Everybody is looking for data for AI in healthcare work for your model development or validation or evaluation. So we curate this for you, provide the largest repository of links to open source data sets right through there. Now, 200 plus databases or data sets available through this link right off our website. And I'll put that in a chat in a moment over here too. You can filter it for the kind of data that you're looking for. You can look at some of the details of the data right on the tile on the website itself, so that you don't have to dig deeper. And you can go directly clicking the link to the data set. Most of these usually require minimal DUA. That's why we classify them as open source data sets. Again, we can't provide the data itself, but we provide you with these links there. We have our podcast series where we feature the stories behind all the people who are working, researching, developing AI in healthcare. You want to learn from them, so please subscribe this for on your favorite podcast channel and listen to their stories and their visions for the future. And of course, the meetings and conferences section where we show upcoming meetings and conferences that you might want to go to, you might want to present your work, or you might want to network with others. So you can catch up on that on in our conferences section. Couple of books from our team over here that might help you get your journey started or catch up with the content. But today's theme is different. So this is our research work from our lab. Every year we do a year in review. We look at the publications from the prior year. We have kept our methodology the same. What stands out in this amongst the group of mature publications is the pillar of radiology. The amount of research and the amount of mature research in this space has outpaced every single healthcare specialty for years together. So we have a lot to learn from that, and that's why we have our eminent speakers over here. It's not just the research part, but also the development part. They have developed a lot of solutions which have gone through FDA approval and are being implemented worldwide. So we again have a lot to learn from that. And again, a lot of these are single, narrow algorithms sometimes. But what's striking to me, and more than agentic AI in healthcare, is exciting to me, is the platform approach. So instead of having these narrow solutions, these narrow networks that do task oriented work, the platforms are going to be the game changer for the future. And that's why we are very excited to feature two speakers, Pranav Rajpurkar, of course, and Vidur Mahajan. Neither one of them need any introductions. I'm not going to spend too much time introducing them over here. You can read about them through the bio through our website. But they have developed these two unique platforms, and we want to hear the stories. We want to learn from them, and we want to learn how to adopt AI in healthcare the right way using this platform approach. So, with that, I'm actually going to welcome Dr. Vidur Mahajan first. He's the founder and CEO of CARPL.ai, and he's going to be talking about the platform approach over there. So, Vidur, you're on. I'm going to stop sharing and hand it over to you. Thank you once again for joining us. We had featured CARPL.ai in the past, and we're glad to have you back here.
No, thank you, Piyush. And it is absolutely an honor it's obviously an honor to be here. And I was just, looking as you were glancing through the slides, a couple of observations. One was my last session was in November 2020, where I actually had like no white hair at that time. My hair looked very much like Pranav's. and and since thank you Amish for that emotion but and also the other thing was how swiftly you moved through the section where you had your own book there. So I think just a learning in humility as well, Piyush. Like the amount of work that you put into BrainX and where you have got it is just like,
No,
I don't know if it's a good word or not, but it's ridiculous.
it's
So,
it's it's a community. It's about community, because for a few years ago, what we realized was, as I was trying to learn about it, a naive physician who didn't even know what Python is except for an animal, and didn't know anything about AI, naively bought Peter Norvig's book and started from page one and knew nothing about it, didn't understand about it. I thought we have to build a community so that we can all learn from each other. And that's where, I've been following and learning from yourself, from Pranav, and so many others on this team. So it's great to have you back over here.
no, Piyush, thank you. You are too kind. I will just share my screen uh, and take you through kind of what we are trying to do at Couple, uh, and what our philosophy, our plan is. Oh, 1 second, I'm stuck in this two screen issue. Just give me 1 sec.
Well, you're stuck with two screens. I deal with five, so
You're not even a radiologist.
I'm not a radiologist. I'm a fake radiologist. Like being with all the radiologists, I've become a fake radiologist now.
of of the session is what it takes for clinicians to start doing radiology. So yeah, exciting to on one screen he has a cricket match going on. I wish I could be that smart. So yes, so can you see my screen, Piyush?
Yes, and I just wanted to note, it's not just one screen. He has a cricket match going. The largest screen is dedicated to that always.
I wish I wish is there a cricket match going on right now?
No, not right now.
No, so yeah, but I can keep talking about that. But yes, coming to Kapil. So once again, thank you, Piyush. Truly an honor. And one is BrainX, of course. Second is to be with Pranav. Somebody I've looked up to ever since. He shook everyone with his seminal paper. In 2017, I think it was Pranav, right, when the whole AI replacement wave started. So it's truly an honor and a privilege. Uh, Carpel is the name of my company. We started formally about 4 years ago. Before that, we were a research group within India's largest radiology service provider, Mahajan Imaging, which is the family business I used to run prior to starting Carpel. Our goal is very simple. We are simplifying the adoption of AI in radiology. The problem we are trying to solve is not a new one. the world has never had enough doctors for all the patients that exist in it. And radiology is possibly the fastest growing field of medicine today. Growing at about 10 to 15% per annum, depending on who you listen to. And primarily because people are living longer and we are detecting disease earlier. And of course, now there are new diseases that we have to deal with. So growing at a very fast pace. And each of these radiology scans, so MRI, CT, X-ray, ultrasound, what have you, needs to be read by a radiologist. And unfortunately, the number of radiologists is growing at only about 2 to 4% every year. And it takes about 10 to 15 years to make one of them. Right. So it's a kind of an expanding demand supply mismatch. But like I said, the world has never had enough doctors for the population that lives there. Right. So not a new problem. And of course, to address this demand supply gap, since the year 2016-17, AI came to the rescue, right? And there have been now, fast forward to today, there's like 1,000 plus US FDA approved AI algorithms for radiology. There's almost 400 plus companies building these AI solutions, all of them addressing the problem of making these radiologists faster, cheaper, better. And in turn, it has never been easier to build an AI solution, right? There is more data than before ever available. You yourself host a database for the data. And, of course, it's never been easier to build AI, right? So very vibrant ecosystem, thousands of, applications, hundreds of companies, so on and so forth, but near zero adoption. Right. So if you go to any hospital anywhere in the world and you ask them how much clinical AI, right? So again, I want to emphasize that we are talking here about clinical AI solutions, which is not scheduling, billing, scribing, all of that. This is hardcore looking at an image and saying what's wrong in it. There are hardly any applications. You go to any hospital anywhere in the world, you ask them how much AI are you using, and the answer you typically get is either zero or lower single digits, right? It's not like folks are using 50 different AI solutions in their practice today. And the reason for that is fairly nuanced. Uh, the first is, how does a healthcare provider even figure out what AI algorithms exist out there? So at the start, Piyush, you had mentioned that most AI algorithms today are very niche, and for us, an AI algorithm is defined as a combination of a body part, modality, and disease. Right. So this triad is essentially what comprises of an FDA approved AI algorithm. And what this also means is that there's a separate solution for head CT stroke. There's a second one for head CT tumor. There's a third one for chest X-ray tuberculosis, and like that there are like tens of AI algorithms, hundreds of combinations that are possible. So how does a healthcare provider even figure out what exists? Next, uh, every provider out there, at least at organization level, needs to trust the AI solutions, right? Of course, end user also has to trust the solution. And in order to trust a solution, the ultimate way, the best way, is to test on their own data, right? So if I am a Cleveland clinic, I don't necessarily need to trust an AI solution that was built in the UK using UK data and works really well in the UK, right? So I want to be able to test on my own local data. That requires data science expertise and time, right? Essentially, which we don't have. So it requires you to run, like if you want to test out 25 different AI, you have to run 25 different pilots, right? And which is a very painful process, both for the company being tested and for the healthcare provider. So very difficult to test these solutions to figure out whether they even work on your data or not, and to build that trust. And thirdly, let's say you've crossed these two hurdles. Thirdly is deployment, right? Every AI algorithm out there has their own input output specifications. right? They show outputs in a certain manner. There are different formats in which you can give outputs, and different formats in which you can consume consume data, etc. So each AI algorithm has a different way of doing it. Each AI algorithm has different infrastructure requirements. Some run on prem, some run on the cloud, some run as Docker containers, some run only on Google Cloud because Google has given them $150,000 of free credits or what have you. So very, very different and variable and non-standard infrastructure needs. And then that is further compounded by the fact that each AI algorithm also has a different user interface, right? Like some want a widget, some have a viewer, some have a blue box, some have a green box, and various different ways in which AI algorithms create user interfaces. And then finally, all of this is compounded by the fact that every customer is also different, right? Every hospital, every health system, every imaging center has a has their own IT systems, their own risk packs, their own cloud or data center or what have you. So it's essentially a combinatorial explosion is the politically correct word that we've come to describe this. Where essentially every time you want to deploy more AI, you face more challenges than you did before because the complexity keeps increasing. So the way to understand this is you are a large health system. You will spend 1 year to take one AI solution for chest X-ray pneumothorax detection, all the way from discovery to deployment. And then at the end of that, you will become 20% faster at 5% of your work. And then, you will spend another year, take a second solution through this entire process, become another 20% faster at 5% of your work. And, by year three, you're like, screw this. I don't want to use AI. It's too much pain. So that's the problem we are solving. Right. And that was also how we came to be because, we were trying to deploy and validate AI across Mahajan imaging. We couldn't, right? We failed. So we started building tools to do that. And today we are a single platform for the end-to-end deployment of radiology solutions. So what does that mean? It all starts with our out-of-the-box AI integrations, right? So we are today the largest AI marketplace of radiology AI solutions in the world. We have almost 175 different solutions from 75 plus different vendors, all of which are available to healthcare providers through first our dev module. Dev here stands for discovery, exploration, and validation. So it is not development, although you can develop AI using CARPL, that's a separate thing. So the idea here is that using a single platform, you can validate many of these AI solutions. You can compare them to one another. If you're an academic institute, you've built your own AI, you can even do that. You can, take your own chest X-ray AI solution, compare it to some open source models, compare it to commercial models, and do all of that in one platform. And then, most importantly, today, monitor clinical AI solutions in practice, right? So you can actually create, charts and graphs where you can say, okay, what is the sensitivity of an AI algorithm last week, last month, last quarter, last year on my own data, right? So it gives you the visibility into the performance of the AI. Once in the discovery, exploration, and validation phase, you have figured out what AI it is that you want to use, you start using it through our deployment module. The deployment module is nothing but a single user interface for AI solutions. So the radiologist doesn't have to navigate 15 different UIs. They just use ours and deal with it. Uh, Secondly, we are a single data layer, single integration layer. So this is more from an IT perspective that IT teams don't need to send data to 15 different APIs, get them whitelisted, have 15 different security clearances, what have you. They send the data to us. We handle the rest. And the same applies to inputs as well. And we are a single procurement channel. So you don't need licensing agreements with 15 different companies. We are kind of like an AI marketplace in that regard, where you can buy AI through us also. The other interesting thing that we've done, this is more recent over the last about 1 year, is we have built deep integration partnerships with PACS providers. So Deep Health, ACFA, IntelliRad, Fuji, Philips are some of the PACS that we have agreements with, where they they resell CARPL as a pre-integrated solution in their packs. So again, it's about making it easier for the radiologist to at least start playing with these AI solutions. Like deployment we will get to in due course, but they should at least start experimenting. And that's what has made us kind of the AI adoption layer for radiology departments across the globe. This is kind of our brag slide. So 4 of the world's top 5 radiology groups today use CARPL. We have we run today about 1.5 million live patients a year through the platform. Of course, this number is increasing quarter on quarter. And RadNet in the US is one of our marquee customers. They are the largest radiology provider in the world. University hospitals, of course, in Cleveland. Uh, we try very hard that we somehow get some osmosis going in Cleveland, but we're still trying. And the Singapore government, so all AI going into the Singapore government goes through us. Unilabs is the largest in Europe. Medica is the largest in UK. Fleury is the largest in Brazil. And these are kind of the largest radiology practices in the world. And then of course, we have research collaborations with some of the world's top institutions. I'll just go into a couple of case studies before I close. Uh, so RadNet, I had mentioned, again, world's largest radiology provider. They have used CARPL. So again, if you just think of us, right, we are a single platform for all radiology AI needs that an institution may have. So they used our dev platform to run 100,000 chest X-rays through 10 different AI algorithms to figure out which one is the best for their specific patient population. Of course, massive exercise, right? You have 1 million different inference outputs, 14 different findings. So you have 14 million data points, right? That now you have to figure out which is the best. So not an easy task, but RadNet kind of took it on. Then we are the pipeline for all AI algorithms there. They are primarily starting with breast, prostate, and lung cancer screening. So cancer screening is a big AI application today. Of course, allows us to also be at the cutting edge of AI, because we have through RadNet partnerships with Google, Hopper, and OpenAI as well. So next is our Singapore deployment. Again, this is same shameless bragging, but we are the single platform for all AI consumption across the island of Singapore through the government. So building, testing, deployment, monitoring, and then subsequent improvement of AI in Singapore is happening through CARPL. In fact, we are working with Pranav and his team as well on a project there. And we've run again 100,000 mammograms through multiple AI solutions to help the government figure out what AI solutions to take into production as they scale up their breast cancer screening program. The next is Latin America. Again, it's a case study for a platform that they moved existing AI contracts to a platform, right? Again, something that is a little, shows the power of the platform approach, makes life much easier for the AI companies. They don't need to worry about support, DevOps, software upgrades, training, etc. We take care of all of it. And of course, for the customer, this is the Albert Einstein Hospital in Sao Paulo. It's just so much simpler that they only have to deal with us. And they are using CARPL to increase their revenue as well by now offering AI as a service to their customers, right? So very, very interesting that we saw. And the last one is probably what I'm most proud of, is where CARPL is now being used at 70 sites across India where there is no electricity and there is no internet, to do AI-based TB screening. Again, we have taken Pure AI's model and Deep Tech's model, put them in the so-called CARPL wrapper. The whole thing gets deployed on a laptop, and then this is the X-ray machine, right? This is the X-ray machine. This is the detector, and there's a laptop around here somewhere. And patients are being screened for tuberculosis, again, in the absence of electricity and internet. And then, of course, we have like a centralized cloud platform where all that happens. But the data, the AI is running on a laptop. So in summary, like our aspiration is to scale the platform approach as AI applications start getting built for more clinically complex use cases. So we are starting with radiology, not to say that radiology is not clinically complex, but we have at least the data to build these applications. So there's a bunch of things that we are doing in the world of radiology today. And then the idea is to go from radiology to other diagnostics, digital pathology, ophthalmology. We've already started, then go into clinical medicine. And one day if there's a robot doing a surgery using some third party AI model, we aspire for CARPL to be the platform behind it. So yeah, with that, I thank you for your attention. If we have time later, I can show a demo as well. But yeah, happy to pass on the baton to Pranav, or do questions now, Piyush, however you want to
Yeah,
handle
I
it.
think we'll do questions at the end because I can imagine some of
Yeah,
them might be common. So
yeah,
we'll take the question at the end. Uh, yeah, it's very, very exciting to see this. And I think you already answered one of the important questions over here. What about like low resource settings and how do you address the application? I can even imagine for cancer screening, you could have a similar approach because there are so many
yeah,
low resource settings where you can't even get any cancer screening.
yeah,
It's an extension for the same. And I also love the approach that it doesn't just get restricted to the radiology part of it, but thinking about a platform that can be built, across the board. I can imagine that the EHR vendors, the large EHR vendors, are probably already thinking, if have not been thinking about the same approach too. So, well, we're gonna welcome Dr. Pranav Rajpurkar to this and have him do his presentation on his amazing work and vision for the future.
Thank you for having me, Piyush, and very good to be here and excited to share the stage with Vidur, who's a longtime friend. So, my presentation, I thought about how to express some of the things that excite me today about where the field is headed. And so I want to start there and then narrow down to what I think is going to be the pathway that with our commercial efforts at A to Z, we're approaching things. Um, it's on top of mind for the past year or so. How do we deploy AI in medicine when AI is starting to surpass human performance across many domains? I just want to give you a sense of how this um, even came to be. So in 2021, some of my colleagues at MIT were interested in understanding whether people will always get better with AI assistance? It's a very simple question. Do radiologists get better when they're given AI? And it turns out no one had at the time investigated this question at a level of scientific rigor to be able to answer it. And so we said we're going to do this experiment, which took about 2 years to do, involved 230 radiologists, where we asked the question, does AI plus the radiologist actually improve the performance over either alone? And for this, we did a study on chest x-rays. But the interesting thing here was that we used a model which was capable of doing multiple findings, as is the case for many commercial models. But at the same time, also the radiologist had access to all of the clinical indication as well as the vitals, the abnormal labs, trying to simulate what information they would see in an actual electronic health record. And we gave 227 radiologists the ability to look at these and decide whether or not 15 conditions existed on each of the AI images with AI assistance, without AI assistance, and with clinical context. So, there was some question of whether the AI model was even good enough compared to the average rad. It comes up all the time. And in this one, it showed that the AI was able to outperform 78% of radiologists. This is without radiologists without using the AI. So it's a pretty good start. But the punchline was that on average, the AI did not improve the radiologist performance on average. It's still zero. And if you look at the breakdown of where it's helping, where it's failing, we can see that when the AI is showing a high confidence, the integration actually works. But when the AI shows prediction uncertainty, it not only doesn't help, it actually hurts the radiologists. Very interesting. Not only doesn't help, it hurts. And so the question comes about, can we detect this in advance? Can we tell in advance someone's not going to benefit from AI assistance versus is going to benefit? Because then what I would do is I would say, okay, these 5 radiologists, they don't benefit with AI assistance. We're not going to give them AI. And the others we are. Or even at a case level, you could say, these cases will not benefit, these cases will. There's been this idea that AI will help the most junior radiologists, will not help the most senior radiologists because they're already good enough, have been practicing for a long time. Or maybe it will help the ones that have experience with AI and not the ones that don't have experience. Turns out none of this is actually true. When you measure it, years of experience, specialty, experience with AI tools are all not predictive of who's actually going to benefit with AI. And this means something very unfortunate for our world in which this one size fits all deployment really fails. And you have to think about how you can measure individual response to AI assistance in order for this collaboration to succeed. Now, we're not the only ones who have come up with these results over the past couple of years. In fact, it's been replicated several times at this point, not just in radiology, but also outside of radiology as well. In fact, if you take a look at some of the work relating to diagnostic assistants, which use LLMs, it's shown recently that it outperforms almost all physicians without the use of AI. And even with the use of AI, the AI is better working independently compared to when having supervision from a physician. And so I want to talk about that a little bit more. Is we've always assumed that the future is going to be this complementary AI plus human working together. And the recent data just goes to show we should really be questioning whether this is the right approach. Certainly, if it is, then the data is not reflective of it. And so this is an article my colleague Eric Topol and I wrote in the New York Times, which was posing the question, are we forcing a collaboration where there might be a better way of creating synergy? And the basic proposal I have in mind is to say, if you provide the AI outputs to everyone in the same way, we're going to create this cognitive friction. In particular, we have very little of an understanding how to help the doctor calibrate to the AI output. So instead, why don't we think about a framework where we separate the roles, where we think about the distinct strengths of the AI and the human, and we have separate yet complementary responsibilities in the diagnostic workflow. So proposal is for a clearer division of labor, separate yet complementary responsibilities, and workflow optimization based on the unique capabilities of each. Okay, so more concretely, what does this look like? Well, I'm going to just show you 2 or 3 examples. The first is going to be one in which you have the AI do the first step, which is going to be the initial review, the documentation. And then we're going to have the second step be done by the expert. Keep in mind, these are not overreads. This is not the expert doing the same thing as the AI. This is the expert doing a different thing than the AI. And then I'm going to share with you an example of a doctor first sequential in which the primary interpretation is done by the doctor. Then there is a step involving the AI for enhancement and education. And then we're going to consider the approach, which maybe is the cleanest role separation, which is going to be if there's a case that's to be read, it either gets read by an AI or by a doctor. And we're going to think about in which cases that makes sense from both a accuracy as well as an economic point of view. Okay, so what I want to share with you is one example of the first case in which we think about how we do this role separation with the AI coming first. And one of the ideas that we've explored academically is the idea of having AI do the patient question asking. So it's going to interact with the patient, ask the right questions, and use that to come up with a differential. So I'll share with you a video of what that looks like. So typically, when you're evaluating a large language model, multimodal, you're going to have images, you're going to have the vignette, and you're going to ask multiple choice question. And the models do pretty well at that today. But this is not how medicine occurs. This is not going to evaluate the history gathering, the ability to understand how these models will respond when you have patients asking questions. So we're going to see how it works in this simulation. So we're going to have a patient AI agent that's going to come in, present their symptoms, and then based on the vignettes it's assigned, it's going to answer questions that are posed by the clinical LLM. Ultimately, the clinical LLM has to come up with a differential diagnosis or a final diagnosis in this case, in which case you can see it's actually getting the answer wrong, that it had gotten right when asked as a multiple choice question. So this goes to say how large language models might fulfill that role in the future, but it's not quite there today, where we see this big drop in performance when you have these standardized question formats being presented to an LLM versus when you have these conversational setups in which we're evaluating large language models. Okay, so I want to share another example, this one more close and near and dear to radiology, where we're going to think about the other aspect of role separation, which is how do we use AI for education and enhancement. And in this work, what we're going to have happen in the workflow is the radiologist does the read, as they usually do, and then we're going to have the AI come in and explain that read to a patient. And so I want to share with you what we've developed, again, on an academic front to make this happen. So this is what the future of the radiology report might look like.
This examination found a hazy, inflamed spot in the left lower part of your lung. This suggests that there could be an infection, possibly related to COVID-19, causing these changes in that area. At the rendering window, there's an orange-colored spot representing this finding. In your CT image, the affected area looks cloudier and denser than the rest of the lung tissue, forming a faint cloudy patch in the outer region of the left lung. In a healthy CT image, you would not see these hazy patches. Instead, you would see mostly dark spaces representing air with a few thin white lines and dots representing normal blood vessels.
Okay. So maybe that's the future of radiology reports in a couple of years. We don't know. Turns out when we gave physicians these reports, these video reports, to ask whether they'd be comfortable sharing with their patients, over time, we've started to see more and more physicians being open to that idea. This particular survey was done with interventional radiologists who often do have to make those explanations to their patients. And you can see this number. I'm comfortable providing this video to patients before their visit, where 46% strongly agreed, but you still have 12% of these physicians who don't want to have these videos be shared with patients prior to visits. I think a lot of what we have talked about might change with the rise of generalist AI models. So Vidur spoke very nicely about this world we're living in today, where you have all of these bespoke models that all sort of operate within their own triad of the anatomy, the modality, and the clinical area. I think there is a world in which we'll have single models that will be capable of doing a wide range of different things. Whether or not they're regulatory approved is another question entirely, but just thinking in terms of capabilities, that is going to be a future. And it's not just the ability to work with images, but in this not so distant technical future, we will have the ability to go beyond images into the EHR, into labs, to not only generate reports, but also explanations, also annotations on top of the scans, And this has been the holy grail within medical image interpretation for a while, but it seems more and more likely that this will be a not so distant reality. So I want to share with you a step towards generalist medical AI that we started in 2023, and this is work under review right now, in which we said we're going to set off to build a single model that's going to be capable of looking at 2D and 3D scans, looking at single scans, looking at multi-view, looking at longitudinal, and being able to take into account natural language instructions, clinical context, and use a single model to solve a variety of tasks. And that was the birth of MedVersa, in which we had a single model that was trained on these 29 million task instances. And what we showed was that on 9 problems where there have been state-of-the-art set by specialized models, we were able to outperform all state-of-the-arts across the benchmarks and set a new state-of-the-art performance on all of these different tasks. This included a different form of validation than has been done in these static evaluations, in which we said for a set of reports or for a set of cases, we're going to have one human written report, one AI written report, and we're going to give them to a bunch of radiologists while they see the image, and they're going to decide which one is better, blinded to the source. And what we found was that on chest X-ray interpretation, 64% of the time they were considered equivalent. 29% of the time the human's report was considered better, and 7% of the time the AI report was actually considered better. I expect this number to change dramatically over the next year. Now, there's been this idea of AI-assisted report drafting around for a while, but with not so exciting a set of results. And what we showed in this work was that we were able to significantly reduce the amount of time that were taken for chest X-ray interpretation, and at the same time reduce the amount of discrepancies between two people reading the same case as a result of using AI drafting. Again, this is work that's yet to be published, but gives you an idea of where we're headed. Today, we host a public competition for tracking progress on this task. The Rex Rank leaderboard is a live leaderboard that allows you to see exactly what the state-of-the-art models are doing today. We have models from Microsoft, from Google on here. And right now, if you look at report generation, our Harvard model is the top on several data sets. And if you look at the visual question answering challenge, it's the Google's MetGemma model that's recently taken first place. So this is a live leaderboard, and you can check out some of the models that people are submitting and are getting to state of the art in the near future. Just as a fun fact, there was a submission by one of the undergrads at IIT Madras that ended up doing pretty well on one of the data sets. And so it's an exciting area where even a small team can have a big effect and impact. So I'm gonna just spend a minute talking about A to Z Radiology AI. So the effort at A to Z is guided by a couple of visions for the future. One is that some of the areas where we're going to have the greatest impact is going to come on complex study types, where we've picked abdomen pelvis CT or chest abdomen pelvis CT as the focus in terms of the anatomy. And when people ask us, what are you trying to do in chest abdomen pelvis CT? My answer is everything. If there is something that we expect a radiologist to do, I would like our A to Z model to do it. And so just to give you a sense of how we've progressed, in September 2024, we could do 20 findings. In December 2024, we could do about 100 findings. And right now, we're able to do about 200 findings on abdomen pelvis CT, many of which are already at radiologist level in terms of performance. and we'll have more public announcements about how we're progressing through on the fronts of report drafting, as well as on detection soon. But I want to show you just a small demo of what this looks like. So here's a case which has been opened. And on the right, you can see already some preliminary lines that are generated by the model. And in the future, we're imagining all the radiologist is trying to do is validate those findings. And if all of those look good, then those serve as the starting point for writing a final report, or that serves as the prelim report that can be signed out and sent, as is done in a lot of overnight telerad settings. So I'll stop there. I think my main idea was to showcase some of what's most exciting on the front of human AI collaboration, and then also share with you some of what's been exciting on the front of A to Z. And hopefully, between me and Vidur, we've managed to cover a lot of what's exciting in our field right now. But we'll pause there and happy to have more of a discussion.
No, thank you, Pranav. This is very, very exciting, and thank you for showcasing some of these studies, some of the work that you have done. There's so many questions that I could ask, but I'm actually going to take the liberty to ask the first question. So we started with the question of AI plus radiologist or plus clinician, and it sounded like that doesn't necessarily work well together. We ended up with AI plus radiologist, and yes, you did fill in between that certain tasks and certain workflow arrangements could enhance the outcome. So is that what's in there? Because one of the key issues that I see today is the regulatory framework that determines everything. You need to write report in a particular format. It needs to go in somewhere in a particular format. So is now the limitation of this autonomous uh, report generation to some extent, or this change in workflow, just like Avnish was suggesting in the comments, that is needed? Is regulation a part of the impediment over there to bring about a significant change in our approach?
Piyush, I feel like we think of regulatory as a bar, and I think part of that bar is a scientific bar. In fact, a large part of that bar is a scientific bar. So let me just comment on the science. I think today, with not almost, I should say, no commercial model will be able to come out and claim, with the exception of mammogram, potentially, mammography interpretation, no one will be able to come out and claim that it is better to have the AI do the work autonomously on any
Mhm.
modality slash anatomy. Certainly not on CT. I just think that's a claim which will not be made. Maybe for chest X-rays, you might see some things with lung nodules. There's the trial which was published in Radiology, which showed 2 out of 1,000 cases had nodules, which were picked up, 0 were picked up by the non-AI arm. So I think when you don't have the evidence, I think you don't have the dreams and you don't have the pathway forward. So I've always believed in science leading the way for the evidence and then the evidence to drive everything else. I just think that, paired with my pessimism that there has been no evidence, is the optimism that the evidence will come in the next year. And if no one else does it, we certainly will. And I think it's a no-brainer in my mind that the technology is just getting better. The trend is getting better. And it's not just that, technology is accelerating at the same rate. It's that the rate of acceleration is increasing. And so it's not the right time to bet against technological progress there. If you think about the limits of what we can accomplish, it's very, very clear to me that we are not bound by data. It's very clear to me that we're not bound by compute. And in that sense, part of the founding story of A to Z was the realization that there was a new kind of a company and a new kind of set of products to be created here. And that's what we've been working hard to do. So we'll have some exciting announcements over the next few months on the kind of science we've been able to achieve. But I think it starts there. And I think once you have evidence to show, this is the way we should be deploying things, then it's very hard to argue against.
Yeah, thank you. We're very excited and looking forward to some of those exciting announcements because I do think I don't have any pessimism on this. I'm an eternal optimist when it comes to AI adoption in healthcare. That's what keeps me going every single day because I believe that yes, we need to leverage the science. But Vidur, let me pivot to you. So as you deploy this across different countries, do you find that as a challenge, or what are the? I think there was a question over here. What are the common barriers that you find implementing like a platform approach, or for even for that matter, like just implementing AI? What's the number one or two? It's the humans, right?
Well, first, Piyush, before I go there, just a slight addition to the previous question, just certain facts. So, when you look at regulation and when you look at, the potential pace of autonomous AI, potential pace, uh, you have to divide the world into US and rest of the world, and maybe rest of the world into the world where a CE approval, a European CE approval works, and a world where no approval is needed, right? So there are like these three different sets of geographies across the world. The US and yeah, I say unfortunately is the most conservative in terms of giving approvals for software as a medical device today, to the extent that they don't give approval today, and kind of correct me if I'm wrong, but they don't give approval today for anatomy, modality, disease. They give approval for anatomy, modality, finding, right? And a disease is a combination of findings. So that's just a long-winded way of saying, and I will say this with an example that the country of Norway, right? They have no lack of money and all that, but they lack manpower. Has recently deployed an AI solution called Occipit, which is a chest X-ray AI solution uh, to autonomously read normal X-rays. Right. So if Occipit says that this X-ray is normal, there is a high likelihood that if it's an outpatient, patient is doing well, no human actually looks at the X-ray and it gets signed out automatically. Now, of course, that is a journey to get there because you still need to sign, right? It's like, but I'm working on a paper with this title. I call it the pathology analogy, right? Nobody's counting RBCs in a Nuba's chamber anymore or counting WBCs in a Nuba's chamber anymore. You put in blood, you get out a number. You trust it, right? You trust the machine. You trust whatever stats is behind the scenes, whatever control systems, but you sign it out as a pathologist. You take accountability for what the machine says, and that's how I feel autonomous AI is probably gonna come in. And there are examples across the world. TB screening is another example. Like there is unsupervised AI running for tuberculosis screening in the remotest parts of the world, as I showed. So there are those few and far between examples that are popping up. To answer the question about challenges with implementation, I think the top challenge we face, I would say, are twofold. First is data security, right? So we also sell to the world's largest radiology groups, and the larger you are, the more concerned you are with data security. So the number one roadblock remains data security. It is, of course, there is ROI and all that, but I'm talking about a challenge where a customer wants AI, but they are unable to get it, right? So the first is data security, infrastructure, etc. Where is the model deployed? Will data go to cloud? Will Google steal my data? Stuff like that. Believe it or not, it happens. And the second is lack of data standardization. So, I find that we exist in this strange dichotomous world where at one end, we have Pranav talking about like an abdomen CT scan getting automatically reported, right? That is the epitome of radiology, and I also know he picked it because it's the hardest. And On the other hand, we are unable to settle on whether we should call it an abdomen CT, a CT abdomen, a TP CT, a CE CT, a God knows what CT, right? And then we have series within that, and you don't know whether to call it arterial portal or whether to call it portal arterial, whatever. So that is the other strangely weird challenge that we face, where a lot of the times. Every imaging center, every hospital, every CT scanner, every tech might have different ways of describing a set of images. And then, once it hits us, we have to figure out what AI to run on it. And it'll be a CT chest, abdomen, pelvis. So we have to figure out which are the pelvic images and which are the abdomen images, which are the chest images, and all that. So these are the two challenges, and I can otherwise just keep going on and on with this.
Yeah, no, those are good thoughts and practical, right? So from your practical experience, sharing that. So thank you for sharing that. I'm going to try to sum up this a whole host of questions into one thing. I think Pranav, you talked about the generalist AI model. So people are asking about like, is there going to be just one model that you see in the future doing all these different tasks? And that's been proposed from Google. You showcased in the research work over there. Is it going to be just one model, or is it going to be a whole host of models working together? And where do you see this going? And one of the challenges that I see with this is because we do in our research lab a lot of evaluation work too, and it's very difficult to do evaluation work even in these narrow task-based scenarios. So once you get into the complexity of different types of data with different outputs and this generalized task and all, it becomes even more complicated. And with all due respect to leaderboards, there has been a counter viewpoint also discussed recently in literature that leaderboards amplify certain biases sometimes. So you can't just trust the leaderboards. They can be a guide, but you can't just go by the leaderboard. So what are your thoughts on this generalist AI model, this agentic approach, where maybe you have a one-stop solution? Is it, we don't do that in healthcare, right? There's a cardiologist, I'm an anesthesiologist, there is a radiologist. Where do you see this going?
It's a great question. I mean, what I know for certain is you don't call one radiologist to read pneumothorax and another one to read pleural effusion and, have them sit together. I think we decided to have some boundaries of what constitutes, a specialty or where you go across specialties. I mean, let's pick, a specialty, like let's say radiology. I would be happy with the level of generality that says you have one model to do image interpretation in radiology. I think I would be even happy, and probably Vidur might be happy as well, if he had, 10 models to deploy as opposed to 1,000, and the 10 models actually covered everything that was required from a radiology standpoint. So I think, when we think of going across specialties, I feel less agnostic because if the workflows are different, then you're going to have less benefit of having a single model anyways, from a deployment standpoint. But on the other hand, if you go to the very extreme, right, like every model of OpenAI is not a specialist, but it has capabilities that rival those of specialists, like the same model that's being used to do legal documents, writing, coding, and some clinical extractions or reasoning. And so if you look at it from a technical standpoint, the answer is very clear. For the answer for the longest time was if you had separate models, they would do their thing really, really well. And that was much better than having one thing that tried to do other things poorly. But that's no longer the case. Now it's for sure the case that technically you always benefit from having a single model compared to having multiple models. And so it becomes more of a deployment and practical consideration in 2025 than it becomes a deep scientific question.
That's great. Let me also piggyback on this question, the customer issue, and we've talked about this in the past. Uh, yes, X-ray interpretation for radiologist is one task, and the evaluation of that is one task. But as we have discussed, when I work in the ICU, I read X-rays every day, and I'm not as good as probably the radiologists reading that. So is it also about who's your point of care customer that you're delivering that information to? Because the use case are many. We saw this with dermatology too, that when you had the AI reading the skin lesions and you provided a dermatologist, well, there was maybe no difference or not enough appreciation for that. But when you give it to a family practice person, they could appreciate it. So is it also about the customer?
Absolutely, of course, Piyush, it always comes down to the end user. And here, I have basically two thoughts. The first is, uh, what if there is a world tomorrow where neurologists start getting paid? See you, Pranav. Thanks for joining. Thank you.
Thanks,
Thank
Pranav.
you.
Uh,
Thanks,
Yeah,
Piyush. Thanks
thank
for
you,
this.
Pranav.
Sorry, I have to run, but
No, no
very
no,
worries,
no
interesting.
worries.
but we
All right.
appreciate it. Yeah.
All right. See you now. Bye.
So I'll also wrap up quickly, but Piyush, essentially the first thought is that imagine a scenario where a neurologist is paid to read the brain MRI of their patient, right? With AI, without AI, whatever the case be, with AI, of course, it becomes easier for them. Like they get the same tool. So that is a potential world. And whenever we speak with radiologists, whenever I am addressing a radiology audience, we always bring this up that if at the end of the day you are simply a report, just you are 100 words, then you end up you know it really doesn't matter who's making that report as long as it's correct. So that is one thought. So as somebody who's building AI, building user interfaces, etc., of course we are building for today, and today regulation demands that radiologists need to sign off on every scan, etc. But there's already like pneumothorax detection has entered the ICU, endotracheal intubation, detection, etc., has entered the ICU and all that. I don't know what's happened to my camera. Yeah, and so that is one kind of thought. The second thought is actually again another strange dichotomy that I only today see with AI, where and it piggybacks Piyush on your dermatology point, where traditionally healthcare innovation has always come from the greatest academic institutes in the world, right? You think of like newer MRIs, CT scans, protocols, whatever it may be, it'll be like the Harvard, Stanford's, Cleveland clinics of the world, where, these will typically first get validated and then, then they percolate across the world. AI for the first time is a technology that is actually meant to make a average radiologist or a generalist radiologist or even an average doctor into a really good doctor. Now, what we are trying to do, but we are following that same traditional approach that we will turn up at a Cleveland clinic and say that, hey, I want to figure out how much better my AI model can make a thoracic radiologist at Cleveland clinic even better. And that person is the world's greatest thoracic radiologist, whereas the product is actually meant for somebody who's in rural wherever in the world, right? And who's dealing with both like neuro and chest and trauma and like a million things. So that's the other interesting dichotomy that a lot of people are now trying to do trials to say that, okay, how is a general radiologist impacted, and how is a subspecialist radiologist impacted, and how is a non-radiologist impacted. Again, dichotomy is these trials are all happening at the world's best institutions, right? So because the others don't have time. So these are just two facts of life. One is that uh, it is true that AI is being tested at the world's greatest sites, and they're not maybe meant for those are not the end users. And the second thing is this whole question about how long will radiologists uh, yeah, what happens if Piyush starts reporting his own X-rays, and if Avnish starts reporting his own X-rays, and whoever else. So that would be very interesting.
Well, we are already doing not for X-rays, but for like POCUS
Yeah.
for the bedside
Oh
ultrasound.
yeah.
And in
Correct.
ICU,
Correct.
we are already doing it. So I think it's a matter
Yeah.
of time before some of these regulatory barriers change. But we are already beyond time. Vidur,
Yes.
thank you so much. And I appreciate Pranav joining us and sharing his thoughts and taking some questions. And I think there's so much to talk about here and so much to unpack. And it's moving so fast that we will have to get you back again, next year to talk more about it. But in the meantime, please follow us. Please follow and all of our content and our platforms for continued learning on BrainX Community. Thank you, everyone, for joining us. And we'll post this on our YouTube channel. So please subscribe. Thank you, everyone,
Thank
for
you,
joining.
Piyush. Thank you, everyone. It's an honor. Thank you.
Thank you.
Bye.